right. Hi, everybody. We are going to go ahead and get started. This is a presentation about kind of frequently asked questions and how the coronavirus vaccination works. My name is, for those of you who don't know me, I'm Zach Kaler. I am a physician here. I'm the assistant medical director for our about 100,000 visit per year emergency department. I also have a master's degree in clinical research. So let's go ahead and move through this. If you are reading through this PowerPoint on your own, and obviously right now you're listening to my presentation, but if you happen to get this by email, make sure to hit slideshow because a lot of these have animations that are not going to make a ton of sense. Okay, so let's start talking just about the conclusion before we even start with the beginning, because this is something that I want you to have fixed in your mind in terms of how the overall process is going to work. So mRNA-based vaccines are a really, really laser-focused way, very clean way of getting your body to create an antibody against one very specific protein, and that's all that it does. So in comparison maybe to some of the things that we have done in the past, such as giving people cowpox in order to vaccinate them against smallpox, which is obviously you're giving someone an infection in order to hope that it combats the other infection. This is a much more targeted, very precise way of doing this. And my goal with this presentation is to give you an understanding of how that works by the end of this so that you can really feel confident in understanding how the vaccine works and why we think that it's safe and effective. So to start, just talking about myself, I don't normally introduce myself with every talk, but in this particular case, it's kind of helpful. So I have a minor in bioorganic chemistry, which is a pretty niche field where you use chemistry, and specifically organic chemistry, to create molecules that interact with biological constructs. And so back in college, we were actually studying different variations of nucleotides and nucleosides that you can use to impact normal human cellular function. And the thing that's really challenging about this is, technically speaking, it's really, really hard to get these to work inside the human body, which, spoiler alert, is one of the reasons that the vaccines are shipped at such an incredibly low temperature. So this was something that I was really interested in all the way back in college. I almost went and did a PhD in this exact field. And I really love this stuff. I really think it's very interesting. And so one of the reasons that I am so intrigued by these mRNA-based vaccines is that it makes a lot of sense to me. It's something that I studied a long time ago, spent a lot of time about, got really excited about back in college. And it's something that, at least theoretically speaking, 15, 20 years ago was something that we knew worked. And now they've kind of worked out a lot of these kinks, which is pretty amazing. The other thing about me is that after I graduated from my emergency medicine residency, I went on and did a research fellowship. So I have, in fact, helped run and enroll in clinical trials. It's not something that I have done a lot of lately. And part of the reason for that is that clinical trials are really, really onerous, and the safety reporting component of them is unbelievably intense. And we'll talk a little bit more about that later on in this presentation. But suffice to say, one of the reasons that I don't do clinical trials, aside from the fact that they're really challenging, is that they can be really frustrating, and you have to report every little minute detail. I also want to mention this is a presentation that is specifically meant for the Moderna and the Pfizer vaccines. The AstraZeneca vaccine works in a fundamentally different way. And so any other additional vaccines that get created through the warp speed process that are going to come available to us, those will all require entirely different presentations. So this is specifically meant for just Pfizer and Moderna. The last thing I want to say about myself was I was actually the 8th person at Prisma Health to get my vaccine. And early on, about 6 months ago, when there was still kind of a lot of chatter about, oh, when are they going to release these vaccines? Are they going to release them before they have been vetted, before they've been approved. Is that something that I'm willing to do? I kind of vehemently told my family and all of my friends that there was no way I was going to get this vaccine without knowing more. And so I mention that because for me, things have changed dramatically, mostly because I've really looked through the science. I've actually poured through the presentation that was given to the FDA by these companies in order to get approved. I was confident enough with this that I have gotten my vaccine. I've actually gotten my second dose of my vaccine. And I really think that this is a scientifically based, safe thing to do. Okay. Who is this presentation meant for? So I wrote this presentation initially for our nurses in the emergency department, many of whom had questions. That has kind of since expanded to other people who are either essential workers or touch the healthcare field in some way. We've had law enforcement people who have been interested in this. Our daycare workers have been interested in this. So a lot of different people who kind of are reasonably expected, because they are essential, to come in contact with coronavirus. And so these are people who can't just hunker down in their houses and stay away from it by being locked in their house for days, months, weeks on end. So within that group, there are also people who are more or less willing to get the vaccine. And so for those of you who are already planning on getting the vaccine but just want a little bit more understanding on how it works, for those of you who are really on the fence, and this is maybe the biggest group that I hope to encourage, for those of you who are kind of on the fence, aren't really sure if this is safe or not, is this something that I want to get? My goal is to give you some reassurance so that you can really feel like you know that you're making an educated choice here. And then lastly, there are also several people who absolutely 100% are not planning on getting the vaccine. And while we disagree on whether or not that's something that you should do, a lot of you still want to hear how this works. And so, I would love for you also to listen to this just so that you have some idea of what's going on, what the science behind this is. My last goal is that my hope is that if you haven't even ever had a biology class, or if you haven't had it since middle or high school, hopefully this is still approachable to you. I mention that because there is a lot of science in this. We are going to go through a lot of specifics about how things work inside of cells, and I really don't think that you can give someone an understanding of how this vaccine works without going through the process of how the virus infects you and how the vaccine causes immunity. So I really don't think that you can make an informed decision without this. The last thing to mention is up front, it is worth mentioning, my goal is to get you to take the vaccine because I think that it is safe and I think that it is effective. With that being said, I am the kind of person that absolutely hates to go and buy a car. I hate used car salesmen. I hate people that try and pressure me into doing something. And so one of the arguments that I've heard thrown around recently has been, well, you have to get your vaccine because the coronavirus is getting so bad right now that now's the time you just have to go and do it. That is not an argument that works for me at all whatsoever. That is not something that has, that kind of high pressured sales pitch has never worked for me. And so if you're one of those people who really does not feel like, that feels like part of what's happening here is that everyone is rushing into this without having the information. I feel you. I understand where you're coming from. That is my goal here, is to give you an understanding of how this vaccine works, why this vaccine works, so that you can make a decision on your own. Feel free to watch this multiple times. Feel free to reach out to me. I've got my phone number and email address at the end of this presentation. Okay. Before we can even get into the vaccine, we do kind of have to talk about phase 1, 2, 3, and 4 clinical trials for just a moment, because there's been a lot of chatter about the fact that we have not finished phase 3 trials with these vaccines yet. And that is true. So phase 1 is really a dosing phase where you take a small number of people, let's say 10, 20, 30, 40, and you give those patients escalating doses of medications to see how much they can tolerate. So think of a chemotherapy drug, which is really, really hard to take. You give people this medication and you want to see how much of it they're able to tolerate. These are smaller groups of people. This is how they establish how much of this medication to give. Phase 2 is really where we get the vast bulk of our safety data from. So phase 2 is where they really truly go in. They have a moderate sized group of people, usually in the hundreds, and they carefully and exhaustively monitor these patients for side effects. So they really go through and they say, what side effects are you having? They ask for specific ones. So they try and elicit specific side effects. With this, we're specifically saying, are you having headaches? Are you having fevers? Are you having chills? Are you having fatigue? Then they also ask, are you having other stuff that we did not know about? So this is really where the vast majority of our safety data comes from, is from phase 2. Phase 3 is your efficacy component, and this is where most trials fall apart. Think of, for instance, Plavix or Lipitor or any of those other, let's say, either blood thinners or some kind of cholesterol agent that are meant to decrease the incidence of heart rate or of heart attacks by like a couple of percentage points. So they do work. They are not as effective as you would think that they would be. So it's not as though you take this medication and you're never going to have a heart attack. And so in order to prove kind of a couple percentage difference between these two medications, you essentially have to have a really, really large, really long trial. So you have to have thousands of people, and those thousands of people have to take this medication for years in order to show that the incidence of heart attacks is different between the patients that are given salt water or placebo and the actual medication. And obviously, for medications that you take a pill on, they make placebo pills, which are don't contain any actual drug. I've heard a lot of people also commenting that we haven't even entered phase 4 yet. That is true. Phase 4 is a kind of post-marketing phase where after you have released the medication, after it has already been approved by the FDA and lots of people are taking it, there is an ongoing kind of long-term monitoring that occurs to see if there's any side effects that happen there, any other major issues. So there is a kind of long tail of all of these things that goes into phase 4. So I thought of different ways to try to come up with a good analogy here. And what I came up with was there's a lot of different ways to cook a chicken. So you can roast it, you can fry it, you can grill it. There's a whole lot of other things that you can do. In the end, you get cooked chicken. And so there's a lot of ways to get to that same thing, but they're all kind of fundamentally different things. I mention this because there are a lot of people out there who are anxious about vaccines in general, or are anxious that this is a new and different process. Fundamentally, there are different ways to vaccinate people. So, like I mentioned early on at the beginning of this, you can inject people with cowpox, with the active cowpox virus, and they will get cowpox. And the side effect of getting cowpox is that you don't get smallpox. So that is one way to vaccinate people. It's not something I personally would really want to go through, but that is one way that you can do this. Fundamentally, there are other ways to do this. And so the mRNA-based vaccines, once we go through the science behind it, I think you'll recognize that this is a totally different way to vaccinate people. This really is going to end up being the future of vaccinations. While it is new, there are papers dating back to the 1990s about this, so about 30 years. And one of the challenges with mRNA-based vaccines, because we know theoretically how it works, is that it's really hard to make these, and then once you've made them, it's also really, really hard to keep them stable. And so this is one of the reasons that you have heard so much about the fact that these medications need to be, these vaccines, I should say, need to be kept at such cold temperatures. mRNA itself lasts only minutes outside of a cell, and so if you were to just accidentally spill a vial of the vaccine on a surface somewhere, that would get broken down in the environment by things called mRNases really, really fast, and it would not survive for very long. So really, it has to go from storage straight into your arm in order to be effective. Even then, once it's in the cells, it only has a half-life of about 24 hours. So the majority of the things that are injected are gone from your system within about 24 hours, which is kind of unique. Okay, so this is the coronavirus. For our purposes, what I want to do here is I want to try and show you two things. We could spend more time on this, but it's not really worth it. So this is the virus. Viruses are not really living. Viruses are mostly just things that happen to be able to replicate because they come in contact with a human cell. And so they are little organisms that don't have a brain or a nervous system or anything like that. They're just able to replicate because they have found a way to hijack human cells to do what they want. And so these pig things around that corner here, these are all spike protein. You've heard a lot about the spike protein. That's what this is. So this is the kind of outward-facing component of the virus that is used to attach to the cells, and it's the thing that allows this virus to gain entry into your cells. The other thing that's worth talking about is this. This is the viral genome. This virus uses an RNA-based genome, which is why our mRNA-based vaccine works as cleanly and easily as it does. Because if you think about it, every protein that this virus makes is going to be held within this genome right here. So each little section of this is going to code for a different thing. So we can imagine, for instance, that this little section from here over to here maybe codes for the pink spike protein, and this section over here is going to code for these little green things, and then this section over here is going to code for the blue things, and so on and so forth. So that is what the cross-section of the coronavirus looks like. It's a pretty good representation of what you actually are infected by. Okay, so before we even get to the vaccine, it is important to go through how the virus infects you. If you are a cell biologist and you already know this, I apologize, this is a little bit simplified. I think you will also agree, though, that it is still accurate in terms of the overall way that things function. And my goal here, again, is to give people a basic understanding of how this process works. So first things first, pay careful attention as we go through this. Now, you can take my word for this, or you can also watch. You will notice that the RNA from both of these processes never either touches the cell nucleus, which is where all of your DNA is stored, nor does it ever enter or merge with or modify the DNA. And so the reason that I have this picture of this medieval scribe here is you can think of your nucleus and your DNA as kind of a library. So all of the books in the library are there. In order to get information out of the library, out of the nucleus, you have to write this down on sheets of paper, and then you take that sheet of paper out. Once it's outside of the library, you can use that sheet of paper to make proteins. But that sheet of paper never goes the other way. So the way that this function goes is you go DNA to mRNA, mRNA to protein, but you never go backwards. It's not possible to do so. And so one of the really neat things about mRNA-based vaccines and also about this virus is that it never actually touches your DNA. It has no way to get in there. And so a lot of the concerns that somehow this is going to modify my DNA or change my genome, that is not physiologically possible. It's not a thing that happens. So you can watch if you care to, and just make sure that I've actually put the nucleus up on all of these cells just so that you can show yourself that nothing ever kind of crosses into there. Okay, so step one, the coronavirus is going to attach to a human cell. So this took forever to make in PowerPoint, but just for our purposes. So this is going to be our human cell. This darker blue around here is going to be the cell membrane. This is made up of something called a lipid bilayer. You're going to hear the word lipids later on. And so for now, we'll just say that this has a bunch of kind of almost oily substance that is going to surround this. This is going to be the coronavirus. So this is going to be a representation of the COVID-19 virion. And we are going to watch as what this does is this moves in, attaches to the cell. So that's step one, is that it uses this spike protein to basically come in contact with the human cell, merge onto it, and then stick with it. Step two is that the virus is going to inject its mRNA into the cell. And again, this is a bit of a simplified example of how this works, but so this mRNA, the viral genome, is going to get into the cell here. Something that's really important to know is that human cells don't have any way of fact-checking mRNA once it's in the cell itself. So once there's mRNA inside the cell, your body is going to take that and create whatever protein that mRNA codes for. So your body has no way of telling, is this my own RNA that I have made that's coding for my own cell proteins? Or is this something foreign? Is this a virus that is doing this? And so there are a lot of viruses that have found ways to kind of hijack your own human cellular mechanisms to create proteins. Okay. So next step is that the mRNA is going to be used, the viral mRNA is going to be used by the human cell to make some viral proteins. So we're going to go ahead and color code this viral mRNA. I stretched this out into one long strand here. This is still that circular yellowish thing from before. So I'm going to go ahead and color code this for you. So we're going to say, just for funsies, that this little red spot right here is going to be the viral envelope. The green thing is going to code for these little green circles, and this purple thing is going to code for the viral spike protein. So we're going to say that each of those components is going to create an individual component of the virus. There's a thing in your cells called a ribosome. The ribosome essentially takes mRNA and reads it off, and once it figures out what that codes for, it creates that protein. And so what's going to happen as we go through is we are going to make the components of the virus because the viral mRNA has entered into the human cells. And the human cell is just going to kind of continuously make more and more and more of these viral proteins. Step 4, once those viral proteins are inside the cell, they are then going to merge and assemble into new viruses. So this is the fundamental way that viruses inject themselves into a cell in the first place, then hijack the cell machinery to make more viruses. Okay, step 5, the next thing that's going to happen is once we have created enough of this virus, it is going to get released from the cells. Again, this is a kind of simplified way of showing how these viruses come outside of the cell, but once they do, now they are out and about, they go and they find other cells, they infect additional cells. And this process happens pretty quickly. And so one of the reasons that you kind of go from like sniffling your nose a little bit to full blown in the bed with fevers is because this process happens exponentially. So once a virus has infected the cell, now it's made a bunch more copies of the virus. Those copies go and infect other cells, and so on and so on and so on. For the process kind of goes up quite rapidly. Next step, coronavirus is going to infect other cells. It's going to repeat this process. And then eventually, antibodies are going to be made by your body against the virus. So this is the end goal here, is to get your body to recognize that there is a virus that we need to make antibodies against. And so in this particular case, these antibodies right here, these guys are the ones that we want your body to have in order for you to be immune to this virus. And so for people who have already had coronavirus, they typically have this antibody floating around in their bloodstream. And once if you come in contact with coronavirus again, the first thing that's going to happen is this virus is the antibody is going to come in contact with the virus. It's going to bind up the virus, and you will then remove the virus from your body. So our goal with the vaccination process is to have all of this happen without having to get coronavirus in the meantime. Okay, so here's the vaccination process, and you're going to notice that a lot of this stuff looks really, really similar to the viral process, and it's because it is basically the same process, except that you don't have to get infected with the virus in order to do so. So step 1, there are going to be the vaccine is a lipid membrane. I was talking earlier about that kind of oily substance. So this is basically something that is able to merge with your cell membranes. It's actually, in some cases, some of the components are the exact same as what make up your normal cell membranes. And then there's going to be a little strand of mRNA inside of those lipids that we then inject into your arm, and they're going to merge with the cells. So let's start by going back to that color-coded viral mRNA that we were talking about before. And what the researchers have done, which is really astounding, is that they have figured out how to just isolate this one little strand of that. So all this codes for at this point is just the protein, the spike protein of the virus. So we've taken all of the other stuff out and just coded for the spike protein. Then that is encapsulated in these little lipids that, like I said, are really basically the same thing as the lipids that surround your human cells. And so what's then going to happen is once that is injected in, the lipids are going to merge with those cell membranes, and they're going to release all of that mRNA into cells. I have this picture of oil and water here. The reason that I have this is that if you have ever dropped individual droplets of oil into water, once they hit each other, they merge together. And the reason that they merge together is because oil inside of water always will clump together. So lipids in general tend to kind of absorb to each other. And so the delivery mechanism for this vaccine is a lipid-based layer that contains copies of mRNA. So the very first lipid layer that it comes in contact with, and that's going to be somewhere inside your human cells, one of your human cells, almost all of which are going to be at the site that you were injected at. Because if you think about oil, you can't have like 2 drops of oil and one kind of like goes through the other one and then out the other side. They just merge together. So the very first cell that this vaccine comes across, it's going to merge with, and it's going to dump its mRNA into the cell. So now, if you think back to what the virus looked like, we basically are at step 2 of the viral infection process, except that the only thing that is inside of your cell at this point is just that little strand of mRNA that codes for the protein. Step 3 is that the cells are going to use that mRNA because, like we said before, your cells have no way of knowing, is this my mRNA or something else's mRNA? So you could theoretically create whatever you wanted to with this. And spoiler alert, down the road, each of these companies have multiple different vaccine candidates for different things that they are working on, because once you have figured out this process, all you have to have is a different strand of mRNA to create whatever protein you want to. Anyway, back to our current process. So the cells are going to use the mRNA, and they're going to make copies of the spike protein. So what we're going to do is we're going to create the spike protein, that gets released, and then the next thing that's going to happen is that all of this stuff gets degraded quickly. About 24, 48, 72 hours after this has been injected is just this protein. So what's going to happen is this mRNA, I just lost it here, but this mRNA right here is going to get degraded by normal processes in the cell into its little individual components, all of which are natural to the human body. And so the only thing that you're left with is this spike protein now floating around in your bloodstream. And the next thing that's going to happen is your body is going to make antibodies against that protein. So it's a pretty neat way. And like I said at the very beginning of this whole presentation, it's a really, really precise way of just having you target just this one protein. So all of the rest of the things that are injected are not immunogenic, so you're not going to make an immune response against the mRNA that is injected. You're not going to make an immune response against the lipids that are injected. You're really just going to make a response against this protein, which is exactly the goal, because once you have those antibodies, they're the same ones that people have against the coronavirus itself once they have had coronavirus. I put up here different vaccine components. So these are all the components that are in the Pfizer vaccine. So as we mentioned before, the mRNA, it's just a strand of mRNA that codes for that protein. There's a lot of big words in these lipids, but it is worth mentioning at least one of them. Cholesterol is a normal thing that is found in all of your cell membranes. For those of you who may have high cholesterol, there is absolutely not enough of this to be concerned about in terms of how much you're injecting into your body. But a lot of these are things that we have used before as normal kind of lipid delivery mechanisms. So, for instance, TPN is a lipid delivery that we use to give people intravenous nutrition. We use propofol as both of these have lipid components to kind of help deliver these. So injecting lipids, this is something that especially me as an emergency physician, we're really familiar with the safe injection of these things. People do fine with these. And then the last components are potassium chloride, which is also known as low salt, if you've ever seen this in the grocery store, table salt, sodium chloride, sucrose, and then these two other stabilizers you can find in like most of the packaged foods that you're going to find in the grocery store. So myself as a physician and a scientist looking at these, none of these things are concerning to me in terms of whether or not I would be perfectly happy to have those injected into my body, which I have. Okay, so let's move on a little bit here to the antibody responses. This is the actual phase 1 trial. I'm sorry my face is blocking this very lowest part here, but So this is how they determined how much of the vaccine to give. So this is a logarithmic scale. So this is going to be 10 to the 1 is going to be 10, 100, 1,000, 10,000, 100,000, and a million copies of antibody, that's IgG, per milliliter that they've tested. Okay, so this is the pre-group right here. These are people before they were even given the injection. And then this is the group that gets a 1 microgram dose, a 10, a 30, and a 50 microgram dose of the vaccine. These little arrows right here are where the booster is given on day 22. And then this group is a group that never got the booster. They never have this little arrow here. And they were given a 60 microgram dose right off the bat, and then they just kind of let it ride. So these are all averages. The reason that these numbers, these bars don't seem dramatically higher than they are with numbers like 25,000 versus 2,000 is because, again, this is a logarithmic scale. So you got to remember that this is an exponential number here. So they ended up settling on this 30 microgram dosing. Once you have had your booster dose, you notice that at day 22, you will have about 1,200 copies of antibody per ml of your bloodstream. After you've had your booster, 7 days later, you have about 17,000 floating copies. So that's pretty awesome. What is really interesting is if you look over here, this HCS, this is healthy control subjects. So this is people that already had the virus. These are patients that were positive for coronavirus at some point in the past, and they measured their antibody levels as well. So on average, people who have had coronavirus in the past, now granted, there is, these could have happened like 9 months ago, these could have happened last week, but people who have measurable doses of antibody have about 600 copies. So one of the reasons that they settled on this 30 microgram dose right here is that you can see we're after about 43 days after your first dose, you've got something like 20 times the immune globulin response, the antibody response against the virus that people did that even had coronavirus in the past. So we think that it's really, really effective off the basis of those numbers from the phase 1 trials. So that's one of the reasons that they chose this 30 microgram dosing right here. To talk about safety stuff, now we're moving on into the phase 2 component of the trial. So the events that they asked about, which are fever, fatigue, headache, chills, vomiting, diarrhea, muscle pain, and joint pain, these are systemic issues. You will notice that in the placebo groups, the people that got an injection of salt water instead of their vaccine, about 33% of them reported being fatigued the day after their injection of nothing. Compare that to the people that had the virus, about 47% of them ended up feeling the same way. So a little bit higher in the vaccine dose, which is not necessarily a surprise to me because you're making an immune response here. You are actually something is happening in your body. You're responding to a foreign thing because your body almost immediately starts making this spike protein. Same thing, similar number of headaches, a little bit higher incidence of fever here. These numbers are also broken up into age 16 to 55 and 55 and above. The reason they do that is because younger people tend to have a higher immune response to things than older people do. And so you will notice that these numbers tend to be higher in the younger group than they do in the older group, both for the vaccine and the placebo groups. And part of this is just because we expect younger patients to have a more robust immune response once they have injections like this. So in terms of overall systemic events, grade 4 it corresponds to 104 degrees or higher. And so there was one incidence of 104 degree fever in a person over the age of 55 here, but everybody else really does fine. And then this is also not repeated in the next group, which is 7 days after dose 2. So what is different, I'm going to go back to this first slide once, is if you look over here at the fevers, about a 4% rate of fevers in patients aged 16 to 55 who get the vaccine. Once you move on to dose number 2, it's about 16%. So that is the one thing that we are really paying a lot of attention to, is that especially right now that we're temp screening everybody coming through the doors, you can expect that there's about a 15% chance that you're going to end up being one of the people that ends up having a fever to this vaccine on dose number 2. Much less likely that's going to happen dose 1, but it's possible on dose number 2. The other thing is you can now clearly see there's definitely a difference in fatigue and headache and chills, muscle pain and joint pain in these patients that ended up really getting the vaccine on dose number 2. And again, this is in a way really encouraging because it means that your body is making an immune response against something. By dose 2, you already have floating antibodies going around. Your body is immediately going to recognize that there is another dose of this protein in, and it's going to really step up that production of antibodies. And so it's not a surprise to me that people who ended up having a second dose ended up having some decent symptoms to it. I myself had no symptoms at all except for pain at the injection site both times. I've heard from some people that they were a little bit tired. So far at Prisma, we've vaccinated, I think, about 13,000 people or so, and we actually have yet to record a severe reaction to any of the vaccines. So that's pretty awesome. Locally, about 80% of people report that it hurts to get a shot, which is kind of like saying that water is wet. None of this is a shock to me, and I don't think it should be surprising to you either. Although it is true that people who got the vaccine versus those who got the placebo are much, much, much more likely to report pain, and I did as well. So that soreness that you have ever gotten from any injections that you've ever had in the past, it's real. You'll probably have it, but that is a small price to pay to be vaccinated for this. I have this picture of a girl who's broken her arm in here, and the reason for this is that one of the things that they start going through is reporting all of the side effects that are not elicited. So again, going back to these are all things that we asked people about. Did you have fever, fatigue, headaches, and chills? They also ask people to report anything else out of the ordinary. And so if you look, this is actually from the AstraZeneca vaccine, but it's a good example, I think, of how this works. They reported that somebody broke a bone about 2 weeks after they got their dose of vaccination. And now the safety and data monitoring group decided that this was unlikely to be from the vaccine. I completely agree. I think it's really unlikely that because you got vaccinated 2 weeks ago, you tripped, fell, and broke a bone. I don't think that has anything to do with the fact that you got vaccinated. But I mention it because I think it's really, really important that you understand the degree of seriousness that these researchers take in reporting every little minor thing. So one of the safety events that is listed in one of these vaccines is that somebody broke an arm. That is really important for you to know, to give you some comfort that they're not hiding a bunch of things or sweeping them under the rug. They are truly reporting every little last thing that could possibly be a side effect. It then goes to a group that evaluates this and tries to figure out, was this actually a side effect that was from our vaccine? So they're really serious. They take this really seriously. The other thing to mention is that there is about zero incentive for Pfizer or BioNTech or Moderna to falsify their safety data. Because what will happen if they do is that 100 million people will get these vaccines. All of us turn into zombies, and the company gets sued out of oblivion. So that is not something that is going to happen. They have zero incentive to falsify this data, because the very first thing that's going to happen if somebody finds out about this is that the company will go bankrupt within days. So that is not something that you need to worry about. If anything, they are probably much, much, much more careful about reporting every little minor thing than they would have ever done before. Okay, so now getting on to kind of the exciting stuff. So this is the incidence of coronavirus after dose 1. So again, placebo, or people who did not actually get the vaccine, they were just given an injection of a placebo. Each one of these little squares is a coronavirus case. So you can see just how many cases happen in the group that gets placebo. The filled in black squares are going to be people that ended up having a very severe case. So obviously a dramatic difference between these two curves. And then the next slide is going to be where they actually blow up the first 21 to 22 days of the vaccine before you get your booster. So you get your booster right here on day 22. But you can see kind of already right off the bat, there's fewer cases of coronavirus right at the get-go. And then by about day 11 or 12, it's really obvious that this curve just completely flattens out. One of the reasons for this is that I have only gone through IgG, which is only one type of antibody that your body makes. You also make something called IgM pretty quickly, which is a much more rapid process, and it occurs when something foreign occurs in the body. And so within minutes of your injection, your body starts making that protein, releasing that spike protein into the body. Your body is very, very rapidly going to start making IgM, which is going to help to mitigate even cases of coronavirus that people are getting early on. Okay, moving on to the FAQ. So these are all questions that I have actually gotten from people about the vaccine. So we'll go through these, and obviously if you have specific questions, feel free to email me. So can I get the vaccine if I am pregnant or breastfeeding? There is no data on this. One of the reasons that there's no data on this is that pregnant women were excluded from the trials. This is not unusual. This always happens. So you essentially always exclude children and pregnant women and a couple of other populations, such as prisoners from your trials. So we don't actually have any data on this. So I'm just going to speak from my understanding of how the vaccine process works. Going back to our oil and water analogy that we have before, the barrier between baby and mom is the placenta, and there are lots of different layers to that. And so there should be no way for this vaccine to go all the way from the location that's injected in. And like we mentioned, the very first set of lipids that it comes in contact with, the very first other oil droplet that it finds, it's going to merge into. So most of this is going to end up going right into the cells in the area around where you actually get the vaccination. Theoretically, if something managed to travel all the way through the bloodstream, didn't hit anything else on its way there, and managed to get all the way to the placenta, there are multiple layers of lipids in between mom and baby. So there should be absolutely no physiological way for this thing to cross through into the placental barrier and get into the baby. Theoretically, even if that did happen, what would happen is the baby would just kind of make antibody against the spike protein, so the baby would come out of the womb being immune against coronavirus. So theoretically speaking, it is not possible. Even if that were to be the case, we already know kind of the process by how this works, and so that's not something that we should worry about. Breastfeeding is much the same way. One of the reasons that you give this by injection is that it does not work if you swallow it, in the same way that, I really wish we could give insulin orally, and I'm sure all of the diabetics in the world do too, but it just doesn't work that way. It gets broken down immediately. And so A, it shouldn't be able to get into breast milk. B, even if it were somehow able to get into breast milk, the baby's saliva and everything else would break it down almost instantaneously. So there really is no way that I would imagine from a physiological standpoint that this should be able to get into baby in either of those two things. Now, with that being said, it is true we don't have any data on this because pregnant women were excluded from the trials. Our OBGYNs here, including our chair, have all come out very strongly in favor of saying that this is something that they still think that pregnant women should get. I am on that same page. And the other thing, in addition to the fact that theoretically speaking this should be safe, is that it is way more dangerous to get coronavirus while you're pregnant than to get an antibody against just the spike protein while you're pregnant. So one way or the other, a very similar process is going to happen. And I really would not want to have you get pregnant, get coronavirus while you're pregnant. I've seen far too many really, really sick people that's just, it is heartbreaking to even think about. Okay. this is one that has come up a lot. Can I get the vaccine if I have previously had Guillain-Barre syndrome or Bell's palsy or some other reaction to a vaccine? And the answer to that is pretty emphatically yes. So first off, there was a study that looked to see whether or not the actual coronavirus, so COVID-19, causes Guillain-Barre. And the answer to that is no. The secondary comment here is that, as we talked about in the previous slides, this is a wholly different process than existing processes. So, this is basically just causing your body in a laser-focused kind of a way to just make one single protein that you then create an antibody against. So this should not cause any of these weird reactions that you potentially expect from actually getting a virus. So there are some viruses that cause things like Bell's palsy or Guillain-Barre. A, coronavirus is not one of those viruses, but B, even if that was the case, the vaccine is not giving you coronavirus, so that is not something to be concerned about. So this is not a live virus. This is not an attenuated virus. What you are being injected with is just the building blocks for the protein. That's it. Should I get it if I have already had COVID-19? And going way back to the very beginning of this conversation, the people that this is meant for are healthcare workers and other essential workers who we really expect are going to come in contact with coronavirus patients routinely. So as an emergency physician, one of the things that I do all the time is intubate patients with coronavirus. They are breathing coronavirus right into my face. And so if there's anybody who's going to get it, it is potentially going to be me. Now I'm wearing a mask and a face shield and all those other things, but even still, you're kind of staring down the barrel of the gun while you're doing this. And so these recommendations are specifically for people who are going to come in contact with people who potentially have coronavirus. If you are law enforcement and you are routinely tackling people and they may be on methamphetamines and they're breathing all over you, you fall into this category. So right now we don't have a ton of information on how long the natural immunity is, because this really has only been going on since like February or March of last year. So we're not even a year into the pandemic. So we don't really have a ton of information on how long you stay immune. I will say in this control group here, again, looking back at this number, these people had about 600 on average copies of immune globulin. There is this one person here, if you look at it, who looks to have like 5. So this person may not be immune to the virus. And so I think that's what we worry about, is that knowing how safe this process is and knowing the science behind how this works, the idea behind saying, yes, you should get your vaccine if you have already had coronavirus, is that some of the things that we're trying to do here is to make sure that you have the highest possible circulating antibody titers in order to make sure that you are still having enough of a immune response. So that's the reason for the booster, is that, again, looking at these people who did not get the booster, they look to basically have around the same level of viral antibodies that people who already had it do. And our goal really is to make sure that you have enough of this that you should be immune for a long period of time. Now, to speculate for how long this lasts, my suspicion is that it's at least 11 months, because we have not seen widespread reports of people getting coronavirus twice. There are a handful of people that has happened to worldwide. It is not everybody who has already had it 6 months later, boom, all of a sudden starts getting coronavirus again. That has not been the case yet. So some of this is that if you've already had the infection, one of the reasons that we're recommending this for is that on playing the numbers game, we know that your antibody levels are higher. So that's the reason for this recommendation. How quickly does the vaccine work? Just to kind of pull that previous slide up here, you should continue to wear masks and do all of the safety things that you have been doing up until this point until 7 days after your second dose of the vaccine. With that being said, you can start to breathe a little bit easier at around day 11 or 12, because it's pretty obvious that the curve starts to drop off like there. I really, really want to emphasize my goal here is not to have you go out and start partying and having a great time after day 11, because there are still cases of coronavirus after that period of time. It's just that that's where we start to see these two curves diverge. We still want you to treat this as though you are not functionally immune up until, about day 28 or so after your initial dose, and 7 days after your booster dose. But again, with all those things being said, please continue to wear masks, because part of this is that you're still going to come in contact with people who have coronavirus. And so you may as well be safe. Even looking at the far tail here, here's a serious case of coronavirus at day 62 within the group of people that were vaccinated. So I believe their definition of serious were people that became hypoxic and were intubated. These are, it still happens that people are getting sick from this. So it doesn't mean that you get a get out of jail free card. It just means that after day 11 or 12 or so, you can start kind of feeling a little bit better about going and showing up to work. What if we only get one dose? Hopefully this has already been answered a little bit, but the benefit of the booster is that antibody titers are 10 to 20 times higher in those who got the booster. So again, here's the non-boosted group, here's the boosted group. So we're talking about 1,000 copies versus 12,000 copies. What's the difference between Pfizer and Moderna? Personally, I view those as essentially the exact same thing. The lipid packaging mixture is a little bit different. The mRNA sequence coding for the protein is basically the same. The way that the packaging, the kind of lipid molecules work is a little bit different, and it allows Moderna to be shipped at not like minus 10 billion degrees Celsius. So Moderna is a little bit more shelf stable. It's a little bit easier to get out to rural areas at this point, but basically they do the exact same thing. And so I would interchangeably get either of those two vaccines without thinking twice. Are there concerns for different blood types? No. So there is some data out there that people with O blood type are less likely to get infected anyway. With that being said, there shouldn't be any relation between your blood type and your body's kind of natural immune response to the spike protein. So that is the body's process of making antibodies is a really standardized way to do things. Should I be worried if I either have current coronavirus or I think maybe, there's a lot of people who swear that like in October of last year, they had this really horrible illness and they tested negative for the flu and they're pretty sure that it was coronavirus. If that is the case, there should still be no concerns about you getting the coronavirus vaccine, because all this is doing is causing your body to make a very short run of additional amounts of this spike protein. And your body will then recognize that as a foreign thing, and it'll either make antibody against it, or if you've already had coronavirus, reproduce the antibody against it. So you shouldn't see any side effects in this. You might be more likely to get a bit of a fever because you are more likely to mount a robust immune response. But again, nothing too major here. This is a really important one. Should I give it a couple of months to see if any new side effects come out? The answer to that is a resounding no. So if you take the two groups, the two phase 2, phase 3 groups from Moderna and Pfizer, and you add them up, about 76,000 people have already had the vaccine worldwide for about 3 months at this point. And in research, there's a concept called person years, where you take all of those people, you multiply that by the amount of time that they have had the vaccine. So right now, we have seen about 19,000 years worth of vaccine in people. So it's called a person year. This is a huge amount of time to be able to kind of like watch for side effects in people. And if there were major and widespread reports of autoimmune diseases or all sorts of, like horrible allergies or things along those lines, we absolutely would have seen that by now. I mean, this is a huge amount of time to have been watching people for, and those things don't really develop like years down the line. They typically develop like within the first couple of weeks to months. So this is not something that I think that we are going to start seeing Once 100 million people have been vaccinated, huge amounts of side effects. The other thing to mention is that there are millions of doses that have already gone out worldwide. And so we already have more than just that phase 2 data of 76,000 people worth of information. There is something else that I really want to mention, and this is more of a fun statistics problem than it is anything else. Once you start getting into the millions of people being vaccinated, one thing that is really hard is trying to figure out which of those people are actually having a reaction to the virus or to the vaccine, and which of those people just so happen to get something. So every day, someone develops a new autoimmune disease. Every day, somebody develops cancer. Every day, somebody develops something else. What is going to happen is that one of those people that is developing an autoimmune response that day will have gotten their vaccine 3 days earlier than that. And that's going to end up being reported. There was already a report of a physician that got vaccinated that died a couple of days later. This is one of those things that is one of the downsides to having worldwide news, is that the news tends to pick up on things like this and run with them and say, hey, there was this guy that died 2 days after getting the vaccine. I want you to know that is going to happen. It is going to be reported, and you should ignore it because statistically speaking, what our goal is to do is to look at the two groups, the people who got the vaccine and the people who got the placebo dose, right? So that's the phase 2 and the phase 3 trials that the data that we're talking about. And you then compare those two and see if there's actually a difference between those two. Because again, when we're talking about large numbers like this, somebody in one of these groups is going to develop something strange. And so you're really looking to see whether or not there's a difference between those two groups. The problem, once you have had 100 million people vaccinated, is that there are going to be some weird things that crop up. And once that ends up cropping up, it will be reported. And there's a lot of people that are going to point to it and say, see, there are weird autoimmune things that happen from this. And so I want you to know that that is going to happen. You're going to see reports of it. And it's not something to worry about unless the researchers look and say, we're actually seeing a difference between these two groups, between the vaccine group and the placebo group. And that is not something that has happened. And we are so far into the data at this point that that is not something that should happen. Okay. People have heard that you can test positive for cancer, herpes, HIV, or even get them. Is that possible? No. The only difference between me right now and me 22 days ago, before I first got my vaccine, is that I have an antibody against the spike protein. That's it. That's the only difference between me now and me then. Again, this is going back to kind of how precise and laser focused this process is. So there really should be no cross reactivity between misspelling of temporary here. Sorry, everybody. Between the temporary creation of a spike protein and any of the diseases that we listed above. Okay, can I wait this out and not catch coronavirus if I'm careful? There was a time about 8 months ago that I would have said yes, that if you are really good about sequestering, we'll get this thing under control. Everybody's going to mask up and we are going to fight this thing and we're going to look like New Zealand and there's going to be no new cases. So not everybody's going to get this. These days, that is not the case. So this is the South Carolina spike lately. So you can see this is around Christmas. I mean, our numbers have just gone through the roof here. We've had like 9,000 new cases, and that has continued to go up over the last couple of days. So the problem is that at this point, this is so prevalent within the community that you will come into contact with coronavirus at some point here. You then from there have kind of two diverging options. You can get antibodies against the spike protein in one of two ways. You can either get coronavirus, which will cause you to get antibodies against the spike protein. Also, you will generate antibodies against the rest of the coronavirus, and you will have gotten coronavirus and possibly had to spend time in the hospital and all the other horrible things that I, as an emergency physician, have seen. Or you can get vaccinated create antibodies against the spike protein, and that way you come out in the same, end game. So unfortunately, at this point, it is so prevalent that the option to just not get it is not there anymore. Does this work with the new strain of coronavirus? Yes, to our knowledge, this actually does still work. So one of the things that happens is the coronavirus can only mutate so much, or else that spike protein no longer binds to the cell receptors. And so that is actually a fairly conserved protein for the coronavirus. It's one of the reasons that it is so infective, and why it is so easily able to jump from person to person. So yes, our antibody against the spike protein still works. Interestingly, if something were to change, let's say in 3 months, a new strain comes out that has a totally different spike protein, it should be fairly feasible for us to genotype that new viral strain, pull off just the spike protein, and create a new antibody or a new mRNA sequence, and then release that. Now, of course, that would also need to go through more trials and testing, but from a safety process, and from a mechanistic process, the thing that is so cool about these mRNA things is that someone, I imagine, is sitting at a computer typing in the sequence, probably copy pasting the sequence from a database of what the genome looks like, and that's how we make that protein, is by basically copy pasting a sequence of ACTG, ACUG, into the computer. Do I have any reactions to pre-existing health conditions? The answer to that is no. So the people that are really asking this are, is this going to cause my blood pressure to go up? Is this going to cause my diabetes to get worse? The answer to that is no. We've not seen any of that at this point. That should not end up being the case. We would have seen a lot of that. They would have reported that everybody's blood pressure goes up by 50 points the day after they get their vaccine. So to my knowledge, no, there are no issues with pre-existing health conditions for this. The one exception is if you happen to be one of those people who has anaphylaxis to an ingredient of the vaccine, and going way back to that slide that listed all of the components of the vaccine. These are basically lipids, which you can't be allergic to because they're in your body. mRNA, which again can't be allergic to because it's in your body. And then those preservatives. So there's table salt, which you're not allergic to. Sucrose, which again you're not allergic to. Low salt, which is just potassium, which again you're not allergic to. And then lastly, there's those two preservatives. And so the vast majority of people are able to eat everything that is in the grocery store. If you're one of those people, nothing to worry about. The number of people that have a reaction to one of those preservatives is going to be approaching zero. This is a new one for me. I heard there's a tracking chip. Believe it or not, yes, there is a tracking chip, but that tracking chip is on the outside of each vial, and it is used to track the doses that they are administering. There's nothing inside the vial. No one is injecting nanobots inside your body. That is not going to happen. Thank you for your time. Contact me if you have any questions. Thanks for sticking with me.